Between 1961 and 1973, the United States detonated 35 nuclear warheads not to destroy enemy targets, but to dig canals, carve harbors, fracture rock for natural gas extraction, and reshape the American landscape. The program was called Project Plowshare, and it promised to turn the atom bomb into a construction tool. Instead, it became one of the most consequential engineering miscalculations of the Cold War. The central question is stark. How did a program backed by the Atomic Energy Commission, prestigious national laboratories, and some of the brightest minds in nuclear physics fail so completely that every single proposed civilian application was eventually abandoned? The answer lies not in a single catastrophic accident, but in a systematic underestimation of radiation, public opposition, and the irreversible contamination left behind. Project Plowshare was organized in June 1957 as part of the Atoms for Peace initiative, a global effort to demonstrate that nuclear technology could serve humanity beyond weapons. The concept was audacious, but technically simple. A nuclear explosion releases enormous energy in a fraction of a second, and if that energy could be directed into excavation or rock fracturing, it might accomplish in moments what conventional explosives required months to achieve. Engineers envisioned using nuclear charges buried underground to blast out instant harbors on remote coastlines, dig canals across Central America as alternatives to Panama, stimulate natural gas production by shattering tight rock formations, and even create underground storage caverns for water or fuel. The physics were well understood. A nuclear detonation creates a shock wave that compresses surrounding material, followed by an expanding cavity of vaporized rock and soil. By adjusting the depth, yield, and tamping material around the device, engineers believed they could control the shape and volume of the crater or cavity. Calculations suggested that nuclear excavation could be 10 times cheaper than conventional methods for massive earth-moving projects. Early tests appeared to validate the concept. In July 1962, the Sedan test at the Nevada test site detonated a 100-kiloton device buried 635 feet underground. The explosion threw 12 million tons of earth into the air and created a crater 320 feet deep and 1,280 feet across. It was the largest human-made crater in the United States, and it seemed to prove that nuclear excavation could work at scale. Engineers measured the volume of displaced material, analyzed the crater shape, and refined their models. Confidence grew that Plowshare could soon move from test shots to real construction projects. Other experiments targeted resource extraction. The Gasbuggy test in December 1967 detonated a 29-kiloton device 4,240 feet underground in New Mexico, attempting to fracture low-permeability sandstone and release trapped natural gas. The explosion did fracture the rock, and gas production increased. 2 more gas stimulation shots followed, Rulison in Colorado in 1969, and Rio Blanco, a triple simultaneous detonation in 1973. But warning signs accumulated with every test. Sedan produced a radioactive cloud that drifted across the western United States, depositing fallout as far as the East Coast. Instruments detected elevated radiation levels in milk supplies. The crater itself remained too contaminated for close human approach. Engineers had assumed that burying the device deep enough would contain most of the radioactive byproducts underground, but the assumption failed. The explosion vented far more radioactive material into the atmosphere than predicted. The gas stimulation tests revealed an even more fundamental problem. The natural gas released from Gasbuggy, Rulison, and Rio Blanco was contaminated with tritium, a radioactive isotope of hydrogen and other fission products. No utility company would purchase radioactive gas. No pipeline would transport it. The very commodity the explosions were meant to extract had been rendered commercially worthless by the method used to free it. Public opposition intensified. Residents near test sites filed lawsuits and demanded transparency. Environmental groups argued that Plowshare treated entire regions as nuclear sacrifice zones. The Atomic Energy Commission had framed the program as peaceful and beneficial, but communities saw their land, water, and air permanently altered without meaningful consent. Proposals for a sea-level canal across Central America, which would have required hundreds of nuclear detonations, collapsed under international protest and the realization that the canal would be impassable due to residual radiation. By the early 1970s, every proposed civilian application had been abandoned or indefinitely postponed. The technical promise of cheap, rapid excavation could not overcome the radioactive contamination, public health concerns, and political backlash. In 1973, the Rio Blanco test became the final Plowshare detonation. The program was quietly shut down in 1977. 27 separate tests across more than a decade had failed to produce a single viable commercial application. Investigators traced the failure to multiple layers. The immediate technical cause was straightforward. Nuclear explosions cannot be made clean. Every detonation produces a spectrum of radioactive isotopes, and no burial depth or containment strategy eliminated the contamination problem for surface excavation or resource extraction. Engineers had underestimated the fraction of radioactive material that would vent into the atmosphere, migrate into groundwater, or remain in the excavated material and extracted resources. The organizational cause was deeper. Project Plowshare operated within a culture that saw nuclear technology as inherently beneficial and radiation risks as manageable engineering challenges. The Atomic Energy Commission prioritized technical feasibility over long-term safety and public acceptance. Test sites were chosen for convenience and security, not for minimizing exposure to nearby populations. Environmental impact assessments were rudimentary or non-existent by later standards. There was also an ethical dimension. Plowshare detonations contaminated land that communities lived on and water systems they depended on, often with minimal consultation or compensation. The program assumed that the benefits of rapid development justified imposing radiation risks on specific populations. That assumption was never tested through genuine democratic processes. The decision-making structure isolated technical experts from the people who would bear the long-term consequences. The legacy of Project Plowshare reshaped nuclear policy and environmental regulation. The program contributed to the momentum behind the Partial Nuclear Test Ban Treaty of 1963, which prohibited atmospheric nuclear testing, and later the Comprehensive Nuclear Test Ban Treaty. It demonstrated that radiation contamination could not be engineered away, and that public acceptance was not a secondary concern, but a fundamental constraint. The Environmental Protection Agency, created in 1970, absorbed lessons from Plowshare about the need for independent oversight of projects with long-term environmental and health consequences. Cleanup efforts continue. The Sedan crater remains a visible scar in the Nevada desert, accessible only on guided tours due to residual contamination. Groundwater monitoring near Gasbuggy, Rulison, and Rio Blanco persists decades after the shots. The sites serve as reminders that some engineering decisions cannot be reversed. The Soviet Union conducted a parallel program called Nuclear Explosions for the National Economy, which involved 124 tests and faced similar contamination problems before its own termination. Project Plowshare failed because it treated a known hazard as a controllable variable. The engineers were correct that nuclear explosions could move Earth and fracture rock at unprecedented scale. They were catastrophically wrong in believing that the radiation problem could be minimized to acceptable levels. The program assumed that technical elegance could override biological reality, and that public concern could be managed through reassurance rather than evidence. By the time those assumptions were proven false, 35 warheads had been detonated, communities had been exposed, and landscapes had been permanently altered. The fundamental lesson is not that ambition is dangerous, but that incomplete knowledge demands humility. Plowshare proceeded with confidence in its engineering, while ignoring what it could not yet measure, predict, or undo. The cost of that overconfidence is still being paid in contaminated groundwater that requires monitoring, in craters that remain off-limits, and in the recognition that some technologies carry consequences that extend far beyond their intended use. The dream of peaceful nuclear construction died not from lack of imagination, but from an inability to separate the useful energy of an explosion from the radioactive burden it inevitably carried. This content is for educational purposes only. Do not attempt to recreate any described experiment or procedure.